Hello, everyone. Welcome to React Conf. I'm really excited to be here. I'm really excited for the stuff that we have to announce for you this week. My name is Sophie Alpert. Sophie Bits on the internet. I manage the React core team at Facebook. By any measure that you use, React is doing great. Our NPM downloads are up 70% year over year. The Chrome DevTools extension for React DevTools has been installed by 1.25 million developers. And I can show you this list of companies that's using React, although at this point it's so long it's kind of hard to tell how much it changes each year. For another point of data, we can look at Google Trends, which shows web search traffic. So searches for React continue to go up. Hopefully that means more people are using React, not that it's getting more confusing. But for a point of comparison, we can look at jQuery, which we have just passed for the first time in history. But this also shows that we have a lot more room to grow. I was procrastinating when I was writing this talk, so I was curious to see what else React is more popular than. Whoops. Spoiled my joke. But React is more popular, I found out, than renewable energy. It's also more popular than orange juice. Just think about how common orange juice is, right? And not only that, it's more popular than renewable energy and orange juice put together. So I think we have a lot to be proud of. But enough about these numbers. What I really like to talk about today is our mission with React. Ever since React was released in 2013, our overarching goal, our primary mission has been to make it easier to build great UIs. And so when we're adding new features, we always try to be very deliberate. We want to consider a bunch of things when deciding whether to add a new API. If it makes it possible to do something you couldn't do before, if it can dramatically simplify the code around React in your components and libraries so that you all have less work to do and users have less code to download, that's a win. Or if it helps encourage best practices like code splitting. If we make it easier to code split your app into multiple bundles, then our hope is that your apps will end up being faster. So that's why we add things like React.lazy, which we announced 2 days ago. You might have seen it. But thinking about this mission, make it easier to build great UIs, there are a lot of different ways that we approach this. One way we do this is trying to simplify things that are hard. If you saw Dan Abramov's talk from JSConf Iceland, then you saw a sneak peek at Suspense, which is our idea about how to dramatically simplify what's required to do data fetching, code splitting, and any kind of async data dependencies in your app. Now, another way we try to improve React is by focusing on performance. If your app runs faster, your users are going to enjoy using it more. Conversely, if your app is laggy, if your app is janky, then your users aren't going to have a great time. So we try to spend time on making React itself faster, because if React is faster out of the box, you all need to spend less time optimizing your own code. One recent performance-related effort that Dan also talked about in Iceland is what we call time slicing. This is going to let you make sure that the most important renders in your app are processed first in order to unblock the main thread and make your apps faster. And a third angle that we approach our mission from is developer tooling to help you debug and understand your app. From the start, React has included developer-friendly warnings to help point out problems before you might otherwise notice them. And we've had the React DevTools extension, which lets you inspect and debug your component trees. And in React 16.5, we introduced a new profiler. It's a second, I don't know what's up with this clicker. A second tab there, profiler tab, that helps you understand what's happening in your app and optimize it. So Suspense, time slicing, and the profiler are 3 of the new features that we've been working on over the last year. We're really excited to tell you more about them, but that's actually not what I'm here to talk about. You're going to have to wait till Andrew and Brian's talk tomorrow morning to hear about that. Today, I want to take a step back and focus on something else. What I'd like to ask is, what in React still sucks? And I have 3 problems that I would like to talk through. The first one is reusing logic between multiple components. In React, our main building block for our applications is a component, And components form the foundation of the two main patterns for sharing code in React apps between components, which are higher order components and render props. Both of these patterns are great for some cases, but they also come with a significant downside. You need to restructure your app anytime you want to pull one of these in. In more complicated examples, this leads to what I call wrapper hell. Most of us have seen component trees that look something like this. And the nesting you end up with makes it difficult to follow the data flow through the app. It would be really nice if there was some way to reuse this sort of stateful logic without needing to change the component hierarchy, right? The second problem I would like to talk about is giant components whose logic is just sort of a tangled mess. When you look at a 1,000-line React component, chances are the logic is going to be split across a lot of different lifecycle methods in a way that's pretty difficult to follow. Let's look at an example. Let's say we have a class component, and in its component did mount method, it does a few different things. It subscribes to a data store, it sends off a network request, and it starts a timer. Well, if we look at the component will unmount method, then we're going to see basically the exact three opposite things. It needs to unsubscribe from the store, it needs to cancel that network request, and it needs to stop the timers. And when it comes to implementing component did update, the logic tends to get even trickier because you need to compare the old and new props and also mirror, again, the same tasks that you have in your other lifecycle methods. In this example, each call here is just one line, so this is actually a lot simpler than what you normally see in your components. In real-world components, you often end up with an even more tangled mess because each individual task has to be split across different lifecycle methods. That makes it hard to tell if, for instance, you forget to clean up one of the resources when you're unmounting your component. It's pretty hard to see that from the code. And the third thing that sucks is that understanding classes in JavaScript can be pretty tricky, and today we require you to use class components in order to access state and lifecycles. If you've ever taken a function component and converted it to a class to add some state, you know that there's a fair amount of boilerplate that's required in order to just define a class component. Most beginners and many experienced devs also tell us that the way binding and this work in classes is pretty confusing. It's annoying to have to think about. And we also frequently hear that people don't exactly know when to use function components, partly because there's always this fear that you're going to have to convert it to a class later anyway. And so you're like, should I do it now? I don't know. And so I claim classes are hard for humans. But it's not just humans. I claim that classes are also hard for machines. If you ever looked at a minified component file, you'll see that all the method names are still unminified, and that if you have a method that's completely unused, it doesn't get stripped out. That's because it's hard to tell at compile time exactly how all the methods fit together. We also found that classes make it difficult for us to implement hot reloading reliably. And finally, when we were prototyping and optimizing compiler to improve the performance of React components, we found that classes can encourage some patterns that make it a lot harder for our compilers to optimize. So here are the three problems that we have: reusing logic, giant components, and classes. So reusing logic because you often end up with this wrapper hell, giant components because you have the logic split across different life cycles, and classes, which are difficult for both humans and machines. So we think we have a solution that can help with all three of these. We're really excited to share it with you. To tell you more about it, I want to welcome up Dan Abramov.
Hi. My name is Dan. I work on the React team. And this is my first time at React Conf. So. And so Sophie talked about these problems that I think most of you have encountered in React development. And of course, we could approach these problems one by one. So we could try to solve them in isolation. But it seems like solving one of them makes some other one worse. So for example, if we try to solve the wrapper hell by putting more logic into components themselves, then our components become larger and harder to refactor. And then on the other hand, if we try to split the components apart into smaller pieces and reuse those, then we end up with more nesting in the component tree, and we get the wrapper hell again. And finally, in either case, we have all the confusion that comes with the classes. So we think that this is because these are not three separate problems. We think that these are three symptoms of one problem. And the problem is that React does not provide a simpler, smaller, lightweight primitive to add state or lifecycle than a class component. And so once you add a class component, you can split it up further without introducing the wrapper hell. And in fact, it's not a new problem. So if you use React for like more than a couple of years, you might remember that when React came out, it actually included a solution to this problem. It was mixins. So mixins allowed you to reuse some methods between classes, and this way you wouldn't have all these wrappers. So should we add mixins back to React? That's right. No, no. We're not going to do that. I mean, the code using mixins still runs. It's not broken, but we don't encourage using mixins in React. And if you're curious why, there is a blog post that we wrote called "Mixins Considered Harmful" on the React blog, where we explain that we think, in our experience, the problems that mixins create are worse than the problems that they solve. So that's why we don't encourage using mixins. So perhaps we just can't solve this problem. Maybe it's inherent to the React component model. Maybe we should just accept it. Or maybe perhaps there is a different way we could write our components that doesn't suffer from either of these problems. And that's what I'm going to talk about today. But before I start, I want to touch a little bit on the way we approach making changes and additions to React, which is a year ago we set up an RFC process. So RFC stands for Request for Comments. And it means that whenever we want to make, or somebody else wants to make a substantial change or addition to React, they need to write up a proposal detailing the motivation and the detailed design of how this should work. And so that's what we're going to do. We're excited to announce that we are ready to present a proposal for how we can solve these three problems. And importantly, this proposal does not have break-in changes or deprecations in it. It is strictly additive. It is opt-in. And it adds some new APIs, which happens when you try to solve problems. And we would love to hear your feedback on this proposal, which is why we're going to publish it today. And we've thought about many ways we could share this proposal. So maybe we just write up an RFC and post it. But since we were going to run React Conf anyway, we just decided to show it here. And we're going to do a demo. It already mirrors the displays. Sorry, technical glitch. Mirror displays. Can somebody who understands projectors help me? Can you make it mirror my desktop? Please. Yeah. OK, but it doesn't show on the screen. I don't see anything. That's the problem that I had. Woo! OK. Disaster averted. All right. Let me tweak the font size a little bit. Do you see it well? All right. So here is a simple React component that just it is a row. This is just some styling, and it renders a person's name. And so let's say that we want this name to be editable. So how do you do it in React normally? Well, like if we want to add an input there, we need to turn this component into a class, add some local state to it, and let that state drive the input. So that's exactly what I'm going to do. That's what we do today. So I'm going to do the expert default class grading extends React component. And so I'm going to use only stable JavaScript syntax. So constructor props, super props. This, the state. I'm going to initialize name to Mary here. And I'm going to declare a random method and copy and paste this. Sorry. OK. And so I want this to be, instead of just rendering the name, I want this to render an input. So I'm replacing this by an input. And the value of the input is this.state.name. And if I make a change, I want to call this .handle name change. That's going to be my change handler. And I'm going to declare it here. When the name changes, we call setState, like we normally do. And we set the name to e.target.value. Right. So now if I edit the, OK, so I need to bind, sorry, I need to bind the event handler. OK, so now I can actually edit it, and it works. So a familiar class component, as if you work with React, you probably write a lot of those. But let's take a step back. What if we didn't have to write a class when we wanted to use state? So I'm not sure how that's going to work, but I'll just start with what I know. I want to render an input. So I'm going to put an input here. And the input has a value, and that value is the current name. So I'll just pass name. I don't know where to get name from. So it doesn't come from props. I'll just declare it, and I don't know. I'll fill it in later. So it's going to have a change handler as well. So I'm going to declare onChange handle name change. And I'm adding a function here, takes an event. And then here, I want to tell React to set the name to something. But again, I'm not sure how to do that from a function component. So I'll just call something called setName with the current input value. And I'll just declare it here. All right, so these two things, they're closely related, right? So one of them is the current value of the name state variable. And the other is a function that lets us set the name state variable. And so because these things are closely related, I'm actually going to put them together as a pair of values. So I'm going to get them together from somewhere. So where do I get them from? From React local state. So how do I use React local state from a function component? Well, what if I could just use state. And pass the initial state to specify it. Let's see if this works. Yeah, it works. So let's compare the two approaches. So on the left, we have a familiar class component. The state has to be an object. We bind some event handlers so that we can access this inside the event handler for this that says state. When we call set state, it actually doesn't just set the state, it merges the argument into the state object. And then when we want to access the state, we do this, that state, that's something. So in the example on the right, we don't need to access this, that state, that's something, because the name state variable is already available in the function. It's just a variable. And similarly, when we need to set the state, we don't need to access this, that's something, because the function that lets us set the name is also available in the scope. So what is useState exactly? useState is a hook. A hook is a function provided by React that lets you hook into React features from your function components. And useState is the first hook that we're going to take a look at today, but there are a few more. So we're going to see them later. All right, so let's go back to our familiar class example. So let's say we wanted to add a second field, for example, for surname. So the way we normally do this is we add another key to the state, and I'm going to copy and paste this row. This is going to say surname now. It's going to render surname and handle surname change. I'm going to copy and paste this event handler. This will be surname. And I need to bind it. OK, Mary Poppins. So we can see that it works. So how do we do the same with hooks? So one thing we could do is we could make our state an object. As you can see that the state, with hooks, state doesn't have to be an object. It can be any primitive. We could make it an object if we wanted to, but we also don't have to. So conceptually, surname is not closely related to state, to the name. So what we could do is we could declare a second state variable by calling the useState hook again. So I'll declare surname. I can give it any name. It's just a variable in my code. And set surname. I call in useState and pass in the initial state for that state variable, Poppins. So again, going to copy and paste the row. Say surname. The value surname, handle surname change. And when the user edits the surname, not surname, we want to set the surname. So let's see if this works. Yay, it looks like it works. So we can see that we can use hooks more than once in a component. Let's compare the two approaches in more detail. So on the left, familiar class component, state is always an object, has multiple fields. We call set state, we merge something into that object, And then when we want to access it, we do this, that's state, that's something. On the right, in the example using hooks, we use the state hook twice. And that declares two state variables, name and surname. And whenever we call setName or setSurname, this tells React that it needs to re-render this component, just like if we called setState. And so the next time React renders our components, it's going to pass the current name and the current surname to our component. And then we can use it directly without accessing this, that state, that something. All right, so let's go back to our class example. What other features of React do we know? So another thing you might want to do from a component is to read context. So context, in case you're not familiar, it's like kind of like global variables for a subtree. So it's useful for things like read the current theme, like visual theme, or the current language that the user is using. And it's useful to avoid passing everything through props if you need all components to be able to read some value. So we're going to import theme context and locale context, which I already declared in another file. And the API you're probably most familiar with for consuming context, especially if you have to consume multiple contexts, is the render prop API. And it looks like this. So I'm going to scroll down here. So we're going to use theme context consumer. That gives us a theme. In my case, it's just going to be a CSS class. So I copy all this code inside the render prop. And I'm going to use class name equals theme. All right, very old-timey. And I also want to show the current language. So I'm going to use local context consumer. And it's going to render another row. So I will copy and paste this row. It's going to say language, and render it here. OK, we can see that context works. And that's how we normally consume context. We actually added a more convenient API for accessing it in classes in 16.6. But this is how you consume multiple contexts. So let's look at how we could do this with hooks. So as we said, that state is a fundamental feature of React. And this is why you can use state. And so if we want to use context, I need to import my contexts. So this is going to be a theme context, locale context. And now if I want to use context from my component, I can use context. And then to get the current theme, I can use context, theme context. And to get the current locale, I can use context, locale context. And this doesn't just read the context, it also subscribes the component to updates to this context. But it just gives me the current value, so I can put it into my CSS class name, and I can add the row. It says language, and I can put it here. All right, so let's compare the two approaches. So this is the traditional kind of render prop API. It is very explicit about what it's doing, but it does get a little bit nested. And you encounter this not just with context, but with any kind of render prop API. So with hooks, it does the same thing, but it's flat. So we just say we use this context, and we get the theme and locale, and then we can use them. So you might be wondering at this point, how can React possibly know? For example, I have these two useState calls. So how does it know which state variable corresponds to which useState call? And the answer is that React relies on the order of these calls. This may be a little bit unusual. And in order for this to work correctly, there is a rule that you need to follow when you use hooks. And the rule is that you cannot call hook inside a condition. It has to be at the top level of your component. So if I do something like if props condition, and then I call the useState hook here, we actually have a linter plugin that is going to complain that this is not the correct way to use hooks. And we realize that this is an unusual limitation, but it is pretty important for hooks to work correctly and also to enable certain things that I think you will like, that I will show a bit later. All right, so let's go back to our class. So the other thing you might want to reach for the class is lifecycle methods. So the most common use case for lifecycle methods is you want to perform some side effect, such as firing off a request, performing some kind of imperative DOM mutation, interfacing with the browser APIs. So you might want to do something like this, and you can't do it during rendering because it's not rendered yet. So the way you do side effects in React is you declare a lifecycle method like componentDidMount. And then let's say that let me show this. So you see at the top of the screen, it says React app. So there is actually a browser API that lets us update this. So let's say we want the tab title to be the name of the person and change it as I type. And so to set it initially, there is a browser API to do this. Is document.title equals this, that state, that name, plus space, plus this, that state, that surname. So now we can see it says Mary Poppins. But then if I edit it, it doesn't get automatically updated because I also need to implement componentDidUpdate for the side effects to be consistent with what I rendered. So I'm going to declare componentDidUpdate and just copy and paste this. All right, so now it says Mary Poppins, but if I start editing it, the document title updates. And this is how we perform side effects in a class. So how do we do this with hooks? Well, the ability to perform side effects is another core feature of React components. So if we want to use an effect from our component, we can import useEffect from React. And then we want to tell React what to do after React has flushed our components to the DOM. So we pass a function, which is where we perform our effect. So I'm going to say document.title equals name plus space plus surname. And you can see it says Mary Poppins here. And if I start editing, it actually updates. So by default, useEffect runs both after the initial render and after every update. So by default, it is consistent with what you rendered. And you can opt out of this behavior if, like, for performance reasons, or if you have special logic. And Ryan Stock, after me, will touch a little bit on this. So let's compare the two approaches. So in the class, we divide the logic based on lifecycle method names. So this is why we have component did mount, component did update. They fire at different times. And we sometimes repeat some logic between them. We could extract it to a function, but still we would have to call it into places and remember to keep it consistent. And with the effect hook, the effects are consistent by default, although there is a way to opt out of that. And notice that in the class, we need to access this, that state, so there needs to be a special API to do this. But in the effect example, we actually don't need a special API to access the state variable, because it's already in the scope of the function. It is declared right above. And this is why the effect is declared inside the component rather than outside, because this gives us access to state variables, ability to set them, and anything else, like the current context value, for example, or any of these contexts. All right, so let's go back to the familiar class example. Another thing you might want to use lifecycle methods for in a class is subscriptions. So maybe you want to subscribe to some kind of browser API, and it gives you some value, for example, the window size. And you want to update the state in response to changes to this value. And so the way we could do this in a class, let's say that we want to monitor the window width. So I'm going to put width into state. It's window inner width browser API. And I want to render it. Let me copy and paste this. So this is going to say width. And I'm going to render it here. This is that state, that width. This is the width of the window, not the width of Mary Poppins. And I'm going to add an event listener. So we need to actually listen to changes in the width. So I'll add window.event, add event listener. I'm going to listen to the resize event, handle resize. And I need to declare this event. And so this is where we're going to update the width state to be window.inner width. And we need to bind it. And I also need to unsubscribe. So I don't want a memory leak with like keeping these subscriptions. I want to unsubscribe from this event. So the way we do this in a class is we create another lifecycle method called component will unmount. And I'm going to copy and paste this logic here, except this will be a remove event listener. So we set up an event listener and we remove the event listener. And we can verify that this actually works by dragging this. You see the width is changing, so it works. So let's see how we could do this with hooks. So conceptually, listening to the window width has nothing to do with setting the document title. So that's why we're not going to put it in that effect. It's conceptually a completely separate effect. And just like we could use state more than once to declare multiple state variables, we can use effect more than once to perform different side effects. So I want to subscribe to window, add event listener, resize, handle resize. And I'm going to need to keep some state for the current width. So I'm actually going to declare another state variable. So I'll say width and set width. We get them by using state with window inner width as the initial value. And now in my handle resize function, I'll just declare it here because it isn't used anywhere else. And it's going to set width to the current width. I need to render it, so I'll copy and paste this row. I'm going to say width. And finally, I need to clean up after this effect. So I need to specify how to clean up. And again, conceptually, cleaning up is part of this effect. So this effect has a cleanup phase. And the order the way you can specify it is that any effect can optionally return a function. And if it does return a function, then React will call this function to clean up after the effect. So this is where we unsubscribe. OK, let's just verify that this actually works. Yay. So let's compare the two approaches. On the left, we have a familiar class component. Nothing surprising there. We have some side effects. Some related logic is split apart. So we can see that document title is being set here, but it's also being set here. And then we subscribe to an effect here. Subscribe to the event here, but we unsubscribe here. So these things need to be in sync with each other. And then this method contains two unrelated lines. So that may, in future, make it a bit difficult to test them in isolation. But it looks very familiar. So that's nice. So this code probably looks less familiar. But let's take another look at what's going on here. With hooks, we separate code not based on the lifecycle method name, but based on what the code is doing. So we can see that there is one effect, which is we update the document title. That's one thing this component can do. And then there is another effect, which is subscribing to the window resize event and updating the state when it changes. And this effect has a cleanup phase, which means that when it's time to remove this effect, React removes it and avoids the memory leaks. And if you've been carefully watching, you might notice that since effect run after every render, we're just going to keep resubscribing. So there is a way to optimize this. So default is to be consistent, which is important if you, for example, use some prop here and need to resubscribe to a different ID from props or something similar. But there is a way to optimize it and opt out of this behavior. And Ryan, in the next talk, will mention how to do it. All right. So there is one more thing that I want to show here. So this component is getting pretty large. And it's fine. So we expect that since you now can do more in function components, they will get larger. And that's totally OK. But you might want to reuse some of that logic in other components or extract it or test it separately. What's interesting, though, is that hook calls, they are just function calls. And components, they are just functions. So how do you share logic between two functions? You extract it to a different function. So that's what I'm going to do. I'm going to copy and paste this. And I'm going to create a new function called useWindowWidth. I'll just paste it here. And so we need the width in our component in order to render it. So I need to return it from this function, which is the current width. And then I can go back up. And I can say const width equals useWindowWidth. So what is this function? We didn't do anything special. We just extracted the function. But there is a convention here. So we are calling this function a custom hook. And by convention, custom hook names always start with use. And so there are two reasons for this. We're not going to read your function name or to string it or anything like this. But it is an important convention because, first of all, this lets us lint automatically for violation of the first rule that I described about calling hooks unconditionally. So if we didn't know if something is a hook, then we wouldn't be able to do that. And another reason is that if you just look at the component code, you kind of want to know if some function can have some state inside of it. So it's important that there is a convention and see, OK, use something, it means that it's potentially stateful. And here, with gives us the current with and subscribes us to updates through it. So if we wanted to, we could even go further. It's probably not necessary in this example, but I just want to give you a sense of what you could do. So let's say maybe setting the document title was a bit more complicated, and you wanted to extract it or test it separately. So I could just copy and paste this. And I could write a new custom hook. I'm going to call this one use document title. And so the name and surname don't really make sense in this hook's context. We just want to call this title. And this is going to be an argument. So custom hooks are JavaScript functions, so they can take arguments and return values, or not return. So it's just going to take title as an argument. And now in my component, I can say use document title, name plus surname. In fact, I could go even further. So in this case, it's totally unnecessary. But again, maybe our inputs were more complicated. Maybe we were tracking whether the input was focused and blurred, whether it has been validated, submitted, and so on. So maybe we had some more logic there. We wanted to pull it out of our components and reduce duplication. And there is already some duplication. So we have this almost identical event handlers. So what if we could just, I'm going to delete one of them and extract the other one. I'm going to create a new hook that I'm going to call useForm input. So this is my change handler. I'll also copy and paste this declaration. So this defines the state for this input. And so it's no longer name and set name. I'll just call it generically value and set value. It's going to take the initial value as an argument. And this is just going to be handle change. And this will set value. So what do we want to get in order to use this use an input in our component? We want to get the current value and a change handler. These are the things that we attach to the input. So let's just return them. Return value and onChange, handle change. So now if we go back up, we can say name equals useForm input Mary. So name is going to be an object with value and onChange fields. And surname is useForm input Poppins. So this is now going to be name.value and surname.value because this is where the string is. And so now I can remove this, and I can spread over the name object. Someone is laughing. All right, let's just verify it and break it. Yeah, it works. So each time we call a hook, its state is completely isolated. And this is because we just rely on the order of hook calls and not on names or anything. So you can call the same hook multiple times. Each call will get its own local state. So let's compare the two approaches for the last time. So on the left, we have a familiar class component. It has some state in an object, binds some methods, has some logic spread across different lifecycle methods, has a bunch of event handlers, and uses some things from the context and renders stuff. Pretty familiar. And on the right pane, this may not look like the React components we're used to, but it kind of makes sense. Even if you don't know how these functions are implemented, you can see, OK, it uses true form inputs, uses some context to get theme and locale, it uses the window width and document title, and it renders a bunch of stuff. And if we want to, we can scroll further, and we can see, OK, so this is how the input works. This is how setting the document title works. This is how the window width subscription works. Or maybe this could be an NPM package, and you don't actually need to know that. Or we could pull it back into a component or copy and paste between components. So hooks give you, custom hooks give you the flexibility to create your own abstractions that do not inflate your React component tree and avoid the wrapper hell. And importantly, these are not two separate applications. So this is actually one application. So I have this window open just to demonstrate that classes can work side by side with hooks. And while hooks represent our vision for the future of React, we don't want to make breaking changes like this. So we need to keep classes working. Let's go back to the slides. All right, now this is a slide you can actually tweet. We present the hooks proposal to you today. Hooks let you use all React features without having to write a class. They do not deprecate classes, but you have the option to not have to write them. We intend to cover all use cases for classes with hooks as soon as possible. There are a few that are missing, but we're working on them. And hooks let you reuse stateful logic, extract it out of components, test it separately, reuse it between different components without introducing the wrapper hell. And again, importantly, it's not a breaking change, completely backwards compatible, strictly additive. And you can find we wrote the documentation for hooks, so you can find it at this URL. And we want to hear from you, the React community. I want to hear what you think about hooks, whether you like them or not. And we realized that it's pretty hard to give feedback without actually trying them. So we built them. And we released 16.7 alpha. So it's not a major release. It's a minor release, but an alpha where you can try hooks. And we've been trying them in production at Facebook for about a month. So we don't expect major bugs there, but the APIs themselves may change together with your feedback. And I ask you not to rewrite anything, like not to rewrite your whole apps in hooks. Because first of all, it's a proposal. And second, because personally, I find that it takes a bit of a mind shift to start thinking in hooks. And it might be a bit confusing if you try to just take a class component and convert it. But I do encourage you to try using hooks in some of the newer code that you write in, and let us know what you think. So, thank you. So in our view, hooks represent our vision for the future of React. But I think they also represent the way we move React forward. And that is, we don't do big rewrites. We want the new patterns that we like better to coexist with the old patterns so that we can have gradual migration and adoption, just like you can gradually adopt React itself. And this is almost the end of my talk. I want to end it on a personal note. So I started learning React about 4 years ago. And one of my first questions was, why JSX? But my second, one of the next questions was, I can figure out, what does the logo have to do with React? So the project is not called Atom. It's not a physics engine. So one interpretation is that it's kind of a pun on reactions. So atoms participate in chemical reactions, reactions react. But as I started playing with React, I actually got I found a different interpretation that made more sense to me. And the way I think about it, we know that physical matter consists of atoms. And we've learned that it's the types of these atoms and their properties that determine how the physical matter looks and behaves. And React has taught me something similar, that you can take a user interface and you can split it into these independent units called components. And it's the types and properties of these components that can describe how the user interface looks and behaves. What's ironic, though, is that the word atom, it literally means indivisible. So when scientists just discovered atom for the first time, they thought, this is the smallest thing we're going to find. But later they discovered an electron, which is a smaller particle inside the atom. And it turned out that actually electrons explain a lot about how atoms work. And I kind of feel the same way about hooks. I don't feel like hooks are a new feature. Rather, I feel that hooks provide me with access to React features that I already know, such as state and context and lifecycle. And I feel like hooks are a more direct representation of React, and that they really explain how a component works inside. And I feel like they've been hiding in plain sight for years. And in fact, if you look at the React logo, you can see those electron orbits there. So maybe hooks have been there all along. Thank you.